Now what we're going to look at today is kind of points in a Cartesian plane, points on a graph, distance formula, midpoint formula, sketching a graph, x, y-intercepts, symmetry, some of the stuff here, but most of this should be pretty straightforward. This should be kind of a review of what you've done in math over the past so many years. So the Cartesian plane is representing real numbers on a real number line. You can represent ordered pairs of real numbers by points on a plane called a rectangular coordinate system or Cartesian plane, which was discovered or kind of named after the French mathematician René Descartes. So in a number plane or coordinate, we have an xy. Now they're numbered 1, 2, 3, 4, and it's going in a counterclockwise rotation. So normally whenever we talk about rotation or degrees, it's going to be counterclockwise. There's going to be the normal rotation. So we go 1, 2, 3, 4, horizontal, vertical, origin. I don't think we need to say much more into this. We know it's an x-intercept if it crosses the x-axis. It's a y-intercept if it crosses the y-axis. For each ordered pair, the x represents the distance from the y-axis, and the y, so on and so forth. If I get 2, 4, we go over 2, up 4. The notation xy denotes a point in the plane in an open interval on the real number line. Yep. Do we need to go over how to plot a point? We feel comfortable with this here? All right, we'll just keep moving. The beauty of a rectangular coordinate system that it allows you to see the relationship between two variables. It would be difficult to overestimate the importance of this because we can visually see scientific and business fields, or because it can be used because we can plot points, we can plot data, we can see how it's trending either up, down, over an extended period of time. They're used a lot. Distance formula. Well, the distance formula is really just derived from Pythagorean theorem, triangle. Because when we talk about any two given points, really we're talking about the distance along C, the hypotenuse of a given triangle. And we can look at it as this here, denoting the 3 points, x1, y2, x2, y2, and x1, y1. Well, the distance between any 2 points is just subtracting it and taking the absolute value of it. So if I want to know the distance along this here, we can say x2 minus x1, and the distance along here, y2 minus y1. So really we're saying that A and B are these 2 values here. A and B. And this is going to be our C. Well, if we square root it, we get this here. Now this absolute values and squares really take care of each other because, again, anything that comes out of an absolute value has to be positive. Anytime we square a number, it's going to be positive. So we don't have to include the absolute value, which does give us the distance formula here. And that's really kind of the origin or the way we can go about proving that the absolute or the distance formula works. So if we want to find the distance of any 2 points, between any 2 points, we use this here. Now the positioning of the x values and the positioning of the y values really doesn't matter. The only thing that really does matter for this here is that we put the x values together and the y values together. That's really it. So if we wanted to find the distance between these 2 points, because our x values subtracted plus the y values being subtracted, and we would get our answer. Now the 2 x values for this here are 3 and -2. Yes? So it doesn't matter which one we put first, because I can say 3 minus -2. And then the other one, I can do 1 minus 4. As long as the y values are together and the x values are together, it really doesn't matter what we do. Because here a negative and negative make a positive. So we'd get 3 plus 2, which is 5 squared. Now if we had it the other way, it would have been what? -2 minus 3. Well, negative 2 minus 3 is negative 5, yes? What's negative 5 squared? 25. What's 5 squared? So it doesn't matter. The order of those two doesn't matter because we'll still get to a positive 25. That's what's kind of nice. 1 minus 4 is negative 3. Now we can square them. 5 squared is 25. 3 squared is 9. 25 plus 9 is 34. And at this point here, we would need to find the square root of 34. Which is indeed square root of 34. Because the only real factors, if we looked at the factor tree, is 2 times 17. 2 is prime, 17 is prime. Those are the only factors. So we actually can't take a square root of 34 and get a natural or integer answer. There's no perfect squares that will come out of it, so that is as simplified as it gets without turning it into a decimal. And if we did turn it into a decimal, it would be a non-repeating, non-terminating decimal, which isn't any nicer than this here. So we'll leave it as the square root of 34. Questions on the distance formula? I don't think we need to see another example of the distance formula at this point. Now, one thing that we can use the distance formula for is showing or verifying that these 3 points are the vertices of a right triangle. Because if something is a right triangle, well, we know Pythagorean's theorem, a squared plus b squared equals c squared, yes? So, if it is a right triangle, then a squared plus b squared equals c squared. Then the Pythagorean theorem works. The Pythagorean theorem only works if it's a right triangle. So, really, if this works, then we know that this is indeed a right triangle. Now, we could go about finding the distances between, well, we can go about finding the distances between each one of these points and then seeing if it does work in the Pythagorean theorem. That's really all we're doing. So we're taking the distance formula 3 times over. So we can do between these 2 points here. So we can say 2 minus 4 squared plus 1 minus 0 squared. And really, you don't have to do this out by hand. You don't have to solve this and calculate this out by hand. I would just plug it into a calculator. And if I was picking between the two, I would use the TI-30XF. Because if I'm working with radicals, or I know that most likely I'm going to have to simplify a radical, I'm going to use the non-graphing calculator. The graphing calculator is going to try to get it to decimal form. It'll approximate it. It won't leave it in radical form. There are ways to do it, but it involves graphing and approximations, and it's more work than it's worth. But if we did this here, I'll just go on and do it by hand. 2 minus 4 squared is negative 2 squared plus 1 squared. Well, negative 2 squared is 4 plus 1 is square root of 5. That doesn't simplify. Now we can do these two here. So we can say 5 minus 4 squared plus 7 minus 0 squared. Well, did not need all that extra bit. 5 minus 4 squared is, well, 5 minus 4 is what? 1 squared is plus 7 minus 0 is 7 squared, 49. 1 plus 49 is 50. Now this would reduce. It would reduce to 5 squared to 2 because 25 times 2 is 50. 25 is a perfect square. Square root of 25 is 5, so it would come out. 2 would stay in. But I'm just going to leave it as this here. Because again, we're checking to see if it's a right triangle, yes? So what are we going to have to do to all these eventually? We're going to have to square them, yes? So I could change it to 5 squared to 2, and if I square that, we get back to 50. Mainly because the square root of 50 squared is 50. I just leave it as a radical, especially if I know that I'm eventually going to have to square it. Or the only way I would really want to reduce it all the way down is if it asked for the lengths of the 3 sides. Then we would reduce it just so we can see it. Now we only have one left. That'd be these two here. So we'd say 5 minus 2 squared plus 7 minus 1. Well, 5 minus 2 is 3 squared. 7 minus 1 is 6 squared. Well, 3 squared is 9. 6 squared is 36. I almost wrote 45. But 9 plus 36 is 45. Any questions on any of this here? Okay. Now we can plug this into the quadratic, or into the Pythagorean theorem to determine if this is a right triangle. Now would it have taken you guys as long as it's taken me to do this? Well, no. For one, you're not having to explain it to somebody, and two, you would have thrown all this into the calculator and been done before I wrote it out. Now, the one big thing we need to figure out is which one of these three is going to be the hypotenuse. Nope. That's what I was thinking. Because 45 is 9 times 5. Square root of 9 is 3, not 9. So we have these three here. Which one's the biggest? The 5 square root of 2, or the square root of 50, yes? Yeah. Because the square root of 50 is going to be the biggest one. Now we just need to put the square root of 45 over here. Square root of 45 squared plus square root of 5 squared is equal to the square root of 50 squared. Do we think this is going to be a right triangle? So when we look at this here, well, the square root and square will cancel, leaving us with 45. Here, the square root and square would cancel, leaving us with. Here, the square root and square would cancel, leaving us with 40 plus 5 equals 50. So is it a right triangle? Yes. Questions on this here? Not too bad. Just a lot of typing stuff in. That's about it. Yes. All right. The next huge topic we're going to cover is midpoint. And this here's the equation midpoint. X1 plus X2 divided by 2, comma Y1 plus Y2 divided by 2 is the equation for midpoint. And again, for this one here, the order in which we put the X's or the order in which we put the Y's does not matter, because we're just adding the two together and dividing by 2. Adding the two together and dividing by 2, and that's it. So I don't have to put the same X first as I put the same Y, or vice versa. The order of this doesn't matter. The main thing is that the X's are together and the Y's are together. So if I want to find the midpoint for this here, well, the two X values are negative 5 and 9. Negative 5 plus 9. Y values, negative 3 and 'We have any guess at what the Y value of the midpoint is going to be? 0. Because negative 3 plus 3 is divided by 2, it's still, that's 0. Now, negative 5 plus 9, or 9 minus 5 is 4. 4 divided by 2 is 2, so the midpoint is 0.20. That's it. Questions on this here? I think we feel comfortable with midpoint, distance, plotting points. And we can have applications like this here. I mean, if I like the concept of these kind of applications, but realistically, I think y'all realize at this point, this is nowhere near accurate of a real mathematical equation. Because we could talk about a quarterback throws a pass from the 28-yard line to the 40-yard line. From the sideline, a wide receiver catches the pass on the 5-yard line. 20 yards from the same sideline as shown, how long is the pass? Well, we can use Pythagorean theorem to figure this out, yes? Does anybody throw a ball at a completely level all the way across? Well, it is possible, but the speed of that pass to go that far would be insane, and most likely there's no way that catcher is going to actually be able to catch that ball, or the receiver is going to catch it. Because we know for any type of pass at any type of level, going 20 yards, it's going to be over 20 yards. It's got to have some type of arc to it for it to be able to make it. There's just no way for someone to do that. I mean, it is possible, but you're still also trying to throw over people so no one else catches it. We actually have to have a parabola to actually figure this out. So we're taking that out. We're also taking out wind resistance. And I mean, there's so many other factors that we're really removing to try to make this as simple as possible so it fits some type of real world application where we can kind of see how it compares or relates. So I'm not too concerned about this here because it's really just distance formula, plugging them in. So we passed at 30 yards. Any questions on this here? Graphs of an equation. Frequently, a relationship between two quantities expressed as an equation in two variables. For instance, y equals 7 minus 3x is an equation in x and y. In order, pair AB is a solution or solution points of an equation xy when the substitution x equals a and y equals b represents a true statement. Essentially, if I plug in a value for x and y and I get a true statement, then that point is a solution. It lies on the graph. So for here, when y is 4 and x is 1, we do get a true statement, so it is a point on the graph. The graph of an equation set of all points that are solutions of the equation. The basic technique used for sketching a graph of an equation is to point plotting method. Essentially, I just get tons and tons of points and plot them and then connect the line that would make that up. And that's it. Next, construct a table showing the solutions in a closed curve. Nope. Because what they're saying is we would take these 5 points, we would plot them, and then we can construct a graph that should represent the equation. Intercepts of a graph. It is often easy to determine the solutions points that had zeros at either the x-coordinate or the y-coordinate, and these are our intercepts. Because at the x-axis, the y value is 0. At the y-axis, the x value is 0. So if I want to find one of them, I plug in 0 for the one that I want. Because if I want to find the x-axis, or where it crosses the x-axis, where the y value is 0, I plug 0 in for y and solve. Or if I want to find out what the y-intercept is, I plug 0 in for x and solve for y. Vice versa. X-intercept, where it crosses the x-axis, is going to be something, comma, 0. Or y-intercept is going to be 0, comma, something. We can find these. Now, some graphs will have multiple x-intercepts. Now, if it is not a function, because the only way that we can have more than one y-intercept is if it's not one function, it's not an actual function. but it is still possible. So we can have one that it has no x-intercepts, but one y-intercept. We can have the case where we have 3 x-intercepts and 1 y-intercept, or 1 x-intercept and 2 y-intercepts, because that's a sideways parabola. Or it could be the case we have none. We have a circle. Note that an x-intercept can be written as an ordered pair A, comma B, and a y-intercept can be written as an ordered pair 0, comma B. I kind of got ahead of it because I already wrote that. Some texts denote x-intercept as the x-coordinate at the points A, comma 0, so on and so forth. Same with y-intercept rather than the point itself. To find an x-intercept, let y be 0 and solve for x. For the y and the y-intercept, let x be 0 and solve for y. So that's, pretty straightforward. It's been pretty much what we've been doing. Yes? Now, they are nice. Most higher degree polynomial functions are nice because it'll tell you what the y-intercept is. If we have any equation in the form y equals a, instead of in x, actually let me call that k, a sub k, x to the n, plus a sub k minus 1, x to the n minus 1, plus a sub 2, x to the first, plus a sub 1, or squared x plus a naught. Really, ak minus 1. That's just a way to state that these are all just numbers. Just a generalization that this is a number. A sub k minus 1, they could be the same number, they could be different, they're just a number. X to the n, so the higher degree polynomial, so we could say that n is 6. So we're talking about x to the 6, and then decreasing in power. This is just the general form of any polynomial function we could ever talk about. All right? If it comes in this form, the y-intercept, you all ready for this? Because again, the y-intercept where it crosses the y-axis, and we know that the value of x is 0, yes? This is your y-intercept every single time. Because again, when we say that we're looking for the y-intercept, it's where it crosses the y-axis, yes? And the value of x is 0. So if that's true, I'm going to get a highlighter. That means any term that has an x is going to become what? 0, yes? So all that I just highlighted became what? 0, yes? Plus this constant term. So the only thing left is the constant term, yes? That's your y-intercept. The only way that this won't work is if this has a power greater than 1. Then we're not talking about a function. Because that's the one that they showed where the sideways looking parabola, that's where we can have 2, that's where this doesn't work out. But vice versa, it actually works for x in that case. Questions on this here? See how this function does not have a constant term, it has everything with variables. So the constant term has to be 0. Or does it cross the y-axis? Y-axis at 0, 0. Does that kind of make sense? Symmetry. Graphs of equations can have symmetry with respect to one axis or the other, or the origin. So we could have it with respect to x, or the y-axis, or the origin, where it's flipped. Cubics, some cubics do have with respect to the origin. Pretty much every single parabola, most parabolas that aren't away from the origin do have respect to y. And I think that's the rotation of 1 over x gives us that first one. But that's a guess. And if we want to test symmetry with respect to x, a graph is symmetric with respect to x if whenever x comma y is on the graph, x comma negative y is also on the graph. If a graph is symmetric with respect to y, whenever x comma y is on the graph, negative x comma y is also on the graph. A graph is symmetric to the origin if whenever x comma y is on the graph, negative x comma negative y is also on the graph. So if we have one, we have the other. Algebraic test for symmetry. The graph of an equation is symmetric with respect to x axis when replacing y with negative y yields an equivalent equation. This here we will look at. This equation here is symmetric with respect to y, reflected across the y-axis. So the graph of an equation is symmetric with respect to the y-axis when replacing x with negative x yields an equivalent equation. So this is our equation when we plug in x, yes? So when I plug in negative x, y equals 4 times negative x squared. Now we want to simplify every place we can. Well, negative x times negative x, or negative x squared. Negative times a negative is a positive, yes? So we get 4x squared. Is this the same as what we started with? Yes. So it is equivalent, or it is the same in respect to x. So this would be reflected across the y-axis. Now, when we reflect something across the x-axis, we replace y with negative y to yield an equivalent equation. Well, the easiest one for this here to look at would be talking about x is equal to 4, well, we could say 3 y squared, because this is a general one. It's just a parabola turned sideways. So if we replace y with negative y, we'd have x is equal to 3 times negative y squared. Well, again, our negative y squared gives us y squared, so these here are the same thing. They're the same function. That's all we're doing, trying to see if we get back to the same thing. Now, the last one we can look at is y is equal to 4x cubed here, our basic cubic function. Now, for it to be reflected or have a reflection with respect to the origin, we're replacing x and y. So that means instead of y, we're going to now have negative y is equal to 4 times negative x to the third. Now, negative times negative, so we're multiplying negative x by itself 3 times. Well, negative times a negative is a positive, times a negative is, well, back to a negative. So we actually get negative 4x cubed. Yep. Well, yeah. We do have a negative on both sides, so what we can do is divide both sides by negative 1, which tells us y is equal to 4x cubed. Because again, we want one of the sides, at least y, to be positive, so we divide by negative 1 or multiply by negative 1 to get it back positive, which actually turns both sides back positive, which is actually what we started with. Questions on this here? Circles are the last thing we're going to talk about. We will learn or recognize several types of graphs from their equations. For instance, you will need to recognize that this here is a second degree equation of the form, this here is a parabola. The quadratic is a parabola. The graph of a circle is easy to recognize because, well, whenever we talk about circles, it's either going to come in the form of x minus h squared plus y minus k squared is equal to r squared. This is the general form. So if we have it in this form, most likely we're talking about a circle. Now, there are other ways that we can write it in a more generalized form where it's spread out, but we won't focus on those too much yet. Because we consider it to be a circle. Wow. If we have this here, well,